students, welcome to the session of remote sensing in GIS. So today we are going to discuss about the spectral reflectance and spectral signature, right? So till now we have discussed the image resolutions, the data formats. What are the data formats? What is image resolution? We have discussed various image resolution, right? So today we are going to discuss about the spectral reflectance. Now student, what does this topic reveals basically? This topic means that spectral. What is the meaning of spectral? Spectral means spectrum, right? Number of bands are present into it, right? Number of bands. So number of bands considers what? Near infrared, far infrared, visible range, microwave range, right? Various ranges are there. That is the electromagnetic spectrum. So here we are going to deal with which object, that is the earth feature, right? Which earth feature reflects how. But here it is known as spectral reflectance. Spectral reflectance means there is a spectrum. So in remote sensing, we have visible range, near infrared range and far infrared range. Okay. So what we will do, the earth feature, for example, vegetation, soil, water body, how it reflects in each wavelength, that we are going to see, right? So here we have already discussed in the topics of energy interaction with earth surface, energy interaction with we have discussed with the earth's feature, right, and atmosphere. So the topics which are related to the transmission, emitted, reflected, absorbed, right? So we are going to see that how much radiation is absorbed and how much radiation is reflected, and if that is reflected, then it is reflected in which range. So why? Because if we know the range, then we could make it out that this indicates this. So here, before starting, I would like to give you here an example. If I have a vegetation image in satellite, and vegetation is very dense. Dense means more growth of vegetation is there. How can I make it out? If red color, because in remote sensing, vegetation is always indicated as red color in satellite image. So in satellite image, when red color is very dark, it is said as dense. So you can make it out that it is reflected more in visible range. That is why it is saying as red color, very dark red color, right? Presence of chlorophyll is very more, that is known as chemical compounds, right? So that indicates that it is a dense forest. When it is light red color, it indicates that it have reflected in blue or red visible range, right? So this is how reflectance curve is indicated, and it is important, then only we can have the feature characteristics of earth feature. Any feature all has this characteristics only, right? So here the main 2 points are dealing with electromagnetic spectrum, that is ranging from visible range to near infrared and far infrared range, right? So let's move further. Here you can see I have written the main points which are important for spectral reflectance. The very first thing is spectral reflectance is basically deals with the percentage of reflectance and the wavelength. Can you see here the figure which I have shown here? You can see the y-axis is considering the reflectance percentage, right? And x-axis is considering the wavelength. Now, look here, wavelength starts from 0 to 2.5. So, what does it mean? From 0.4 to 0.7, it is visible range, and from 0.7 to almost 2.5 to 2.7, it is considered as short wavelength, short infrared wavelength, long infrared wavelength, and then it starts with the longer wavelength, that is microwave and radio waves, right? But we are not dealing in the spectral reflectance in microwaves and radio waves. We are dealing just with the visible range and near infrared and far infrared, right? So first of all, spectral reflectance. Any material has some characteristics of reflection, right? That is known as reflectance, right? Every material has reflection value because these energies are stored in sensor, and we want the reflection value, then only we can make it out that what does that feature says in the satellite image. Because student satellite image are taken from almost how many kilometers away from the earth? 36,000 kilometers away, and that is why this is important. Then only we can fetch that the vegetation is available in green wavelength, right? Water is, for example, available in visible range. This is how you have to fetch the objectives in the electromagnetic spectrum, right? Now moving further here, I would like to give you the present scenario condition that we all are dealing with the pandemic, that you all know there are wave 1, wave 2, and right now we are preparing ourselves for wave 3, right? And that is what, that is coronavirus. Again, virus is what? It is the virus which can be visible on the electromagnetic spectrum. If it would have been visible in the spectrum, then the solution which is found out for the virus eradication was powerful, but it was not visible in the spectrum. Even the scientists were and laboratory personnel, lab technician are trying to find it on the electromagnetic spectrum, because what it is the virus, airborne virus. So it is there in the air and it is entering to the human bodies. So yes, there was a possibility to find out that virus in the air, and then we can make it out on the spectrum and we can have the good research and scientific approval for that. But we haven't do that, and we are not successful because this virus is not visible in the spectrum, right? Not in any of the range it is not visible. And this electromagnetic spectrum is the generalized spectrum, right? For every each and every purpose, electromagnetic spectrum remains the same. It does not change, right? So we didn't see that where that virus is observed. We cannot see. Now, in day-to-day life or even when we were small, you have seen when sun rays are coming directly from outside and window is there and that is coming in your room. Have you seen there are the particles who are revolving around that rays? Have you seen that? What is that? That are the particles present in the atmosphere. So they are visible particles when sunlight falls. So that is also visible on the electromagnetic radiations also, right? So this is how the science deals with. I guess you are clear with the examples what I said. Now when we are taking the images from, for example, the surface, that is from the space, right? Then I have to have the proper information. Why? Because I am taking that remote sensing is the technique, without coming into the contact I can have the information, right? So here it is specially dealing with that. So we are learning this reflectance curve. It is called as reflectance curve also. It is called as spectral curve also, and it is called as signature reflectance, spectral signature. So we can make it out that in which range which object is properly visible. Right, student? I guess you are clear with what I mean and why we are doing this reflectance curve. Spectral reflectance curve. Spectral means there are various bands are present into it. That is why it is said as spectral reflectance. Right? Now, let's move further that we have already seen and discussed. I have already told that each property, each material has some other characteristic which reflects, which absorb, right? So these all reflected energies are stored in the sensor and then we do the analysis of the satellite image, right? So here the definition of spectral reflectance curve is indicate that the relationship between the percentage reflectance and the wavelength of given material is called as spectral reflectance, is called as spectral signature, right? So always when there is a vegetation and vegetation has a good amount of chlorophyll, then it will fall in this range only. If it has less amount of chlorophyll, then it falls in other range. This is the example what I can give you, right? Now there is also a one important point, student, in spectral reflectance, that it does not show us any characteristics of absorption or transmission. Which process was this absorption and transmission? This process are basically considered during the energy interaction with earth feature. So they don't provide us any information. But spectral reflectance will give us the information that how much energy is reflected, percentage of reflectance, right? So this is why it is important, right? So it will record the reflected energy. That is why spectral reflectance is important. Right now, here I have taken the very major earth features, that is vegetation, soil, water, snow, and cloud. You have to identify majorly these objects on the earth feature only, and then you have the urban areas also. You have the wastelands also. These are the various, but these are the major parameters that have the good reflectance value in different conditions, right? So let's discuss first of all from the following. Let us discuss for the vegetation. Now for the vegetation, you can see here I have shown here the graph. Can you see on the right side I have shown the graph? Yes. So here you can see I have also shown the scale, that what is a visible range, what is a near infrared range, what is a far infrared range, right? You can see that also clearly. Now see to the graph of vegetation. Can you see the graph of vegetation? How it is increasing, it is decreasing, it is increasing, it is somewhere stagnant, and again it is decreasing. What happens towards that? Right? So in the vegetation, let's have the detailed example of it. Look to the image which is opened now, which has a detailed example towards it. Can you see this image? This is for the vegetation only. Look, you can see when chlorophyll is present, see in the range from 0.5 to 0.7 to 0. Somewhat 67 in middle, right? They show some energy is decreased and increased. See, the graph is somewhere when it is starting from 0, it is decreased. Then it is somewhere increasing above 0.5%, right? Then it is again decreasing. So what does it indicate? When there is a chlorophyll present, it will absorb the strong radiation in the range of red and blue, but it will reflect in green wavelength. So what it indicates? In green wavelength, the vegetation will be reflected more when chemical compound like chlorophyll is present, right? But in red and blue, it will not reflect, right? It will absorb the energy, so it will not reflect, but in green wavelength it will reflect, right? So this is what it means. Then we have the season wise difference reflectance, right? In summer season the vegetation is differently reflected. Might be possible that it reflect more in the blue color. Why? Because season is changed. Again the radiations are coming from the space bone, that is from the satellite, so they might have good radiations and good energies in the band blue or band red. Then it will be different scenario, right? Reflectance value different. This is what I have explained, the generalized. I have not taken here any season. I have just said if chlorophyll is present, chemical compounds are present, then this happens. Then you can see what is the water absorption. Then you have the mesophils, what I have shown, but you don't have to go in detail towards that. You have to remember this only, that in red and blue when chlorophyll is present it absorbs less energy, but you have seen that if it is in green wavelength it will reflect, right? Then you can see when we are moving ahead in the wavelength, it is again increasing. Why? Because when we are talking the vegetation, right, it might be a vegetation of trees. Then trees and trunks are seen differently in the different wavelength. When I talk about limbs and canopies, they are differently reflected. So it shows the different impact of it, right? So this is how it works on. So somewhere the energy is increasing means the reflectance. I am talking here energy in the reference of reflectance. So reflectance is increasing and decreasing. Somewhere it is getting stagnant means there is a variation in the characteristics of material, right? Surface materials variations are there. If I'm talking about trees and canopies, then you can see here that it will be reflected more in shorter wavelength. If I talk about tree trunks, the harder portion of tree trunks and leaves, it will be more reflected in the longer wavelengths, right? So this is how you can have the spectral reflectance for vegetation, right? I guess you are clear with the spectral reflectance of vegetation and actually what I mean when we say the spectral reflectance, how much energy is reflected in which spectrum, in which wavelength, right student? Now we are going to discuss similarly for the soil, right? What are the soil characteristics? I guess with the example of vegetation, you are clear that how is the detailing of vegetation spectral reflectance is shown. Similarly, all the characteristics of soil are also seen. Basically, soil consists of water, and you all know that low moisture, high moisture content soil are there. There are various types of soil: coarse soil, sandy soil, loose soil, right? Water contained soil, right? There are various types of soil present. So, how can we identify the soil characteristics? Now, see to the graph of the right hand side image I have shown the combined graph of vegetation, soil, and water. See to the graph of soil. Can you see the graph of soil? What does it indicate? See how it is percentage is increasing and how it is decreasing and what is the stagnant into it. How can I know this? By the characteristics of moisture contained into it. Right? So I will tell you here, when there is a sandy soil, means the desert soil or the coarse soil, moisture content will be low and it will have the highest reflection. Right? It will be having the higher reflection. But when there is a presence of moisture, right? But when there is a presence of moisture and soil is loose, right? Then it will be having no reflection, right? Because soil contains water into it. That is why, right? Soil is loose, basically. So what happens in the image of satellite when you have the loose soil? Means reflectance will be less. So what happens? It is not clearly seen. It will be seen black and green, somewhat type black and brown. So you can make it out that soil contains some water. Black and brown are mixed color. So you can make it out that watery soil is present, loose soil is present, in which moisture content is there. But when you see the clear brown color in the satellite image, then it will be seen, or clear brown color or clear light brown color as seen in the image, then you can say that this is high reflectance because soil is low moisture content. Right, student? So this is how moisture characteristics changes and the properties of soil changes. Whole Gujarat, whole country India have different soil characteristics at different regions of India. Right? Now, similarly, we are going in detail for the water content. What is the water content? Can you see the water content what I have shown? Water map means I meant to say water graph. You can see here. What does it indicate? When clear water, it reflects. Turbid water, it reflects. Sometimes it reflects good, sometimes it reflects less. Both the things are possible, right? So you also have the water is shallow or deep. So shallow will reflect more energy, deep will reflect less energy, right? So it all depends on how the radiations are coming, how the radiations are interacting with the surface feature, and how it is reflecting back again to the sensor. Right, student? So I guess you are clear with this water. Now let me tell you in detail about the water characteristics. What does it mean when I am saying that it is a water, and what does it indicates? Basically, you can see here when I talk about water, what does it says? When it is a clear water, means a crystal clear water, distilled water, it will be having less particles present into it. Less total solids are present into it. So what happens? That water will have good reflection energy. But yes, there is no such water that is crystal clear. So what happens? There is always some deviation into the reflection portion of water. Similarly, when turbid water means the water is dirty, water is not clear. It reflects sometimes good because the presence of some particles or chemicals, something which are present into it, then it will reflect good energy. But if some chemical compounds are present in such a way, then it will reflect less energy. Right? Basically, we use this turbid water analysis for the factories which are there. From the satellite image, we can make it out that here is some factories. That is why this water is seen like this. You can make the difference of it. The color difference will be there. So you can make it out that in which range it is reflecting, in which range it is not reflecting, right? So these characteristics we can make it out about the water. Similarly, we have for the soil. What does soil says? We have discussed low moisture content, high moisture content, and for the vegetation, how is chlorophyll present? You can discuss about it. Each features are properly indicated. And lastly, we can see about snow and cloud. In the visible range, both have the high reflectance, right? So when range changes, there will be some change, but it depends that in visible range both will be having the high reflectance, and that is visible in the visible range only, right? So snow majorly we are not talking for country India, because you all know snow is not much there. On the northern parts, yes, we can talk in the similar some period of time in a year, right? That is in February, January, December, we can talk about it. Similarly, snow is especially for the Himalayan regions that is having the glaciers present into it. So when the landslide occurs during that period of time, we fetch this frequency and we can see the landslide, why it is occurring, why, what are the characteristics of snow is changing. So snow and clouds are clearly visible in the visible range of electromagnetic spectrum. So this is all about what is electromagnetic spectrum, which is related to the spectral reflectance. Right? Now students, look here, I have shown you the satellite image. Can you see all colors are properly indicating what it is? When you can see a red color, it means it is a vegetation. When you can see a light blue color type, it is called as urban areas. It is CN. When you can see the black color dots or black color, it is a water present into it, right? So this is just an example I am showing you, that in satellite image how is the reflectance. With the color combinations you can make it out, and with the colors we can only do in the spectral resolution, right? So that is why it is known as spectral reflectance curve, right? Spectral signature. Here, there might be a color difference and change you cannot see because image is very sharp, right? Some tools are applied on it, so image has been sharp. If the image is raw, you can see the color differences. But in the urban also, you can see the color differences. See, the lands, wetlands, you can see black and somewhere it is white dots are also seen. See to the image clearly, you can see what I mean. There is a white surface patches are also there. There is a black surface, red surface, combined surface are also there. This means there is a presence of some of the other characteristics which has the chemical component. If it is a salty land, then it is representing as white. If there is a salt in the land, it is representing as white. If water contains salt, then it represents white. If water contains some particles into the water, then it indicates white color type, right? So these are the things which spectral reflectance tells us, that how much energy is radiated. I guess you are clear with the topic of spectral reflectance, and you are clear with what is spectral signatures. So student, here the module gets over about the fundamental of remote sensing. Please go through all the lectures, you can have the detailed view about it. So here we have discussed about the various sensors, spectral reflectance, right? We have seen the image resolutions, we have seen the signature portion. These are the important topics which are related to the fundamental of remote sensing. We have the launching vehicles, which is known as GSLV and PSLV, that is geosynchronized and polar synchronized. The data, how it is captured. If I want vertical data, that satellite should move vertically around the Earth's surface, and it is known as what? Polar synchronized. If it is moving in the horizontal direction, then it is known as geosynchronized, right? Orbit, satellite, there are various platforms, airborne, spaceborne, right? So it all deals with the fundamentals of remote sensing. I guess you are clear with this topic, that is spectral reflectance of each and every object on the Earth's surface. Thank you.